In this video, I am going to go through the entire process of solving a linear programming problem that has mixed constraints. Now, I've worked out most of the problems on here just to save time. Otherwise, this would be about a 20-25 minute video. So we want to maximize p equals 6x plus 12y plus 4z, subject to these three constraints. Now, the first thing that we want to notice is that this has mixed constraints. Because we're maximizing and we have mixed constraints, which means specifically that this is a greater than or equal to sign. This is a non-standard maximization problem. Non-standard maximization problem. If this last inequality was a less than or equal to, it would be a standard maximization problem. So to solve a non-standard maximization problem, the first thing that we have to do is to create our system of equations. So starting with the first inequality, we have x plus 2y plus 5z. And because this is a less than or equal to symbol, we add a slack variable. So I added a plus r. In the second inequality, 4x plus 12y plus 7z, again, there is a less than or equal to sign, so I added plus s as my slack variable. In the third inequality, once again, because this is a greater than or equal to symbol, we have to subtract a surplus variable. And I explained the difference between the slack variables and the surplus variables in another video. So if you need to, go back and take a look at that. Finally, the objective function, 6x plus 12y minus 4z, we subtract those terms to the other side. We add the plus p equals 0. And so this is our system of equations. From the system of equations, we have to create our initial table. And so we are going to have an x column, a y column, z column, r, s, t for our slack and surplus variables, p, and then our constant column. The coefficients in the x column are 1, 4, 2, and negative 6. The y column, 2, 12, 5, negative 12. Z column, 5, 7, 1, negative 4. And then R, we only have an R in the first constraint, so we have 1 and then zeros. S is only found in the second constraint, so we only have an S in the second row. Everything else is zeros. T, we only have a T in the third constraint, and notice that it's a minus T, so we're going to have a minus 1 in the third row of the T column. And then finally, P, we only have a P in the last row, so we have 0, 0, 0, 1 in the P column. And then our constant columns, 1, 4, 26, and 0. So we've set up the initial tableau, or I just like to call it a table. Now, first thing that we notice is that this is not the solution. And the solution, it's not the solution because we have negatives in the bottom row. We have a negative 6, negative 12, negative 4. And that's generally always going to be the case, but I just like to point that out. So the question is, do we have any negative active variables? So our active variables are R, S, T, and P, which I've labeled on the left-hand side. And we do have negative active variables. In the first table, we're always going to have at least one negative active variable. Because of this negative T here, we have this negative value right here. And so our active variables are R. R is equal to 100 divided by 1, which is positive 100. S is equal to 420 divided by a positive 1. So that's a positive 420. T, however, is 60 divided by a negative 1, which is negative 60. Whoops. So we have a negative active variable, and then p is positive, 0. So because we have this negative active variable, we have to do this thing called phase 1. And so I'm going to highlight the T row because that has a negative active variable. So the question is, how do we go about finding our pivot? Well, to determine the pivot column, when you have a negative active variable, you always go to the row with the negative active variable. And so we're going to have to go to the T row. And we look for the largest positive number in that row. And the largest positive number in the T row is 50, not including the constants. Is the 5. And so this becomes our pivot column. The Y column is the pivot column. Then to determine the pivot, we look for the number with the smallest ratio. And so the smallest ratio is going to be, once again, you can probably hear that helicopter flying over. I'm in my garage. So in this column, we're looking at 100 divided by 2 is 50. We're looking at 420 divided by 12. And then we're looking at 60 divided by 5. And I'm not sure what 420 divided by 12 is, but it's going to be larger than 60 divided by 5, which is 12. So that means that the 5 is our pivot. Okay, the 5 is our pivot, which means we have to make everything else into a 0 in that column. And so we use our standard row operations to do that. So this is what we call phase 1. We go to the row that has a negative active variable. We look for the largest positive number. That becomes our pivot column. We then look at the ratios within that column, and we look for the smallest ratio. So that number is the 5. We then clear that column using row operations. And so that brings us to the second table. Now, what are the actual row operations? Well, let's just take a quick look at what those might be. So to get rid of this 2, to make that into a 0, that 2 right there, I would probably do, remember we want to do the changing row first, so probably do something like 5 row 1 minus 2 row 3. And then to get rid of this 12, I would do 5 row 2 minus 12 row 3. And then to get rid of this negative 12, using the pivot, I would probably do 5 row 4, and because that's a negative, I would do plus 12 row 3, plus 12 row 3. 5 row 4 plus 12 row 3. That's a little bit messy. Let me rewrite that. Plus 12 row 3. Notice I'm always doing the pivot row last. The row 3 is the pivot row. All right, so that gives us our new table. And so we notice that we are not done with this problem because the bottom row, the P row, has negative values in it. But are we still in phase 1 or phase 2? And so we look at our active variables. So now the active variables are R, S, Y, and of course P. So R, we take the 380 divided by 5. Well, that's going to be a positive number. S is 1380 divided by 5. That's a positive number. Y is going to be 60 divided by 5. That's a positive number. So they're all positive. There are no negative active variables. No negative active variables. So we are done with phase 1, and we can now begin phase 2. Now, in some of the problems, you're going to have to do phase 1 2, maybe even 3 times before you get rid of all of the negative active variables. All right, so what is phase 2? Phase 2 is the very first method that we learned for solving standard maximization problems. We go to the bottom row and we look for the most negative number. And so in our table, most negative number is negative 8. So T is our pivot column. And we look for the smallest ratio. So we would have 380 divided by 23, 1380 divided by 23, 60 divided by 1. Remember, the pivot always needs to be positive. So it looks like 23 is going to be our new pivot, which means we need to clear that column. So once we clear that column, we're going to have a new table. Now, how are we going to clear that column? Well, to get rid of this 23, I could just subtract the 2 rows. I would probably take row, our pivot row is row 1, so I do row 2 minus row 1. Row 2 minus row 1. To get rid of this 1, I'd need to multiply it by a negative 23, so I could take negative 23 row 3 plus row 1. Yeah, that would work. Negative 23 times the 1 would be negative 23, plus my pivot 23 would be 0. Now, what about getting rid of this negative 8? Well, 23 and 8, I'm just going to multiply them by each other to get the least common multiple. So for this one, I'm just going to do 23 row 4 plus 8 row 1. And that should give me a 0 there. So once we do all that, we have a new table with new active variables. And so, are we done? And the answer is, of course, no, we are not done, because we have negatives in the bottom row. So we do the process over again. We look for the most negative number, which in this case is the negative 260, so that becomes my pivot column. And so it has to be a positive number, so it's either the 2 or the 10. 380 divided by 2 or 1,000 divided by 10. So it looks like 10 is going to be my pivot. And so to get rid of this 2, we're going to probably do something like, 5 times row 1 minus row 2. To get rid of the negative 25, I would probably do 10 row 3 plus 25 row, 2. I think that would work. 10 row 3 plus 25 row 2. And there's other ways you could do that as well. I could have done it a different way. And then to get rid of this negative 260, well, I think the easiest way to do that is just going to be row 4 plus 260 row 2. Row 4 plus, not 260, I'm sorry, 26. 26 row 2. 26 times 10 would be 260. 26 row 2. So row 4, negative 260 plus 26 times the 10 would be 260, and that would give me a 0. So you clear, and what do we get? We get a new table. And finally, not finally, we still have negatives. Still have a negative. Negatives, negatives. And so, one more time, largest negative number is negative 260. We're looking for a positive number. And so it looks like our pivot is going to end up being 10. And so we clear that that column. And so to clear that column, I would probably do 2, row 2, plus row 1. That would get rid of this, make that a 0. 2 times negative 5 is a negative 10, plus the 10 is 0. I would do, let's just say 10, row 3, minus 65, row 1. That's one way you could do it. There are other ways. I avoid decimals. I could have done row 3 minus 6.5 times row 1. And then for the last one, I would do row 4 and plus 26 times row 1. So row 4 is negative 260 plus 26 times 10 is 260 would give me 0. So those row operations should clear our columns, and we should end up with this. And so now we notice the bottom row, all positive. And so once we have all positive numbers or zeros in the bottom row, we can determine our answer. So our active variables are x, t, y, and p. So to find the x, we take 900 and we divide it by 10, and we get 90. I skipped the t because I really don't care about the t, but the t would be 2,900 divided by 20. The y I really want to know. So y is 11,500 divided by 2,300, and that gives me 5. And p is 69,000 divided by 115, which gives me 600. Everything else is 0. The value of r is 0, s is 0, and z is 0, because they are not active variables. Inactive variables are always 0. So finally, the solution to this, the optimal value, is p equals 600, and that occurs at x, y, z, 95, and 0. So there's a lot of work in this problem, and there's a few of the problems in the homework that are going to be a lot of work like this. Just take your time, do it step by step, be very methodical, check your work each step of the way, and you'll do just fine. All right, so hopefully this was helpful.